Hey guys, this is Jacob, chemistry tutor here. We're going to take a look at this one. So the question, if I take a look at that, we have a 10-gram sample of calcium carbonate. It's heated strongly, undergoes a decomposition reaction, breaks down into calcium oxide, which is a metal oxide, and carbon dioxide. And for part A of this question, we want to know what the theoretical yield of carbon dioxide in grams is. So for part A, we need a theoretical yield. So we need two things. We need the molar mass of calcium carbonate and CO2. And we also need a mole to mole ratio between the two. So if we have the molar mass of calcium carbonate, I'm going to look at my periodic table here. We can add up the mass of calcium, which is 40.08 grams in 1 mole, plus the mass of 1 carbon, plus the mass of 3 oxygens here. When we add up all that, that adds up to be just about 100 grams per mole. So that's the molar mass, 100 grams per mole of calcium carbonate. For CO2, we have the mass of carbon, which is 12, and we have 2 oxygens. So 2 times the molar mass of each oxygen, which is 16. So that's going to be about 44.01 grams per mole. If we look at our balanced equation here, we have calcium carbonate breaks down into calcium oxide plus CO2. We can take a look and see if this is a balanced equation or not. We have 1 calcium on the left, 1 calcium on the right. We have 1 carbon on the left, 1 carbon on the right. We have 3 oxygens on the left, 3 oxygens on the right. This is a balanced equation. So our leading coefficient for all 3 of these would be 1. Okay, so we're starting out with a 10-gram sample of calcium carbonate. All right. So we need to set up some dimensional analysis. So we calculated our molar mass. In that, for every 100.09 grams of calcium carbonate, that is equivalent to 1 mole of calcium carbonate. Our mole-to-mole ratio is 1:1. So for every 1 molecule of calcium carbonate that breaks down, we form 1 molecule of carbon dioxide. For every 1 mole of calcium carbonate that breaks down, we have 1 mole of CO2 that's formed. So for every 1 mole of calcium carbonate that breaks down, we get 1 mole of CO2 that forms. Now, if we want to yield in grams, we can go back to our molar mass and say 1 mole of CO2 is equal to 44.01 grams of CO2. All right, so we can do our work at that point, and our theoretical yield comes out to be 4.40 grams of CO2. So that's our answer for part A. For part B, it says we actually, so our actual yield is 3.21 grams of CO2. So what's our percent yield? So our percent yield is pretty simple. All we got to do is take our actual yield divided by the theoretical yield and multiply by 100 to turn it into a percentage. So all we got to do is take 3.21 grams, which was the amount that we actually recovered in this decomposition, plus 4, or divided by, 4.40 grams of carbon dioxide. We can label those two times 100, and that comes out to be 73.0%. So not a bad yield, but we definitely lost more than we would have thought. So this is part A. This is part B. What's the role of limiting reactant? It's simply the only reactant we have, calcium carbonate. So once that decomposes, we can't form any more of a product, even if we have enough heat available in order to decompose more calcium carbonate. Thank you, guys.